start with the programming here. So we're going to go right back to basics here. So the first thing we need to go through is the searching and sorting algorithms right here. There are two of these algorithms that you were taught. Do you remember the names of them?
Binary search and linear search.
Okay, so let's start with search. Uh, okay, binary and linear. So how would binary search work?
Like divides it into two, and then
Finds the
find the
middle one,
middle
doesn't it?
value. Yeah.
Yep, so if I were to give you a target value, find the number 42 in this array. Now the thing is, what needs to be with the array? As in,
Or the list.
yeah, so the list needs to be ordered first for binary search to work. So if I were to write the numbers 4, 8, 15, 16, 23, 42. So how would binary search work in this list?
So you get like the amount of numbers and you like divide by 2 plus 1,
Okay, so
don't
that
you?
gives you, so this is like you kind of find the median if this is a bit linking to math as well. So um it would kind of use these two values, get an average, like 15 and a half. Okay, so what would it do with 15 and a half? And then knowing that,
It won't match.
yep, so compare 42 to 15 and a half.
It won't match.
It doesn't match,
42 is
but
bigger.
okay, good. So 42 is bigger. So basically what binary search does now is it gets rid of this. So it doesn't have to search anything there, and that saves a lot of time. So now we got only this list to focus on here, this mini list. So it does it again. Which is our middle value?
23.
Okay, 23 is our middle value. So we compare it again to 23. Is it smaller or larger?
Smaller and bigger.
Bigger. So 42 is bigger than
Yeah.
23. So we'll get rid
Yeah.
of
That.
everything before that, as well as 23 itself. And since this conveniently leaves us with 42, which is only left, is 42 equal to 42?
Yep.
Okay, good. Whereas if we were to do this again on a linear search is actually quite easy to do. If I write these out again, so talk me through how linear search would go through this list here. So
Like go through each individual one.
okay,
Like
so which
each
one do we start at?
4 and 8.
So just 4. So remember, we're
Just
just
4. Yeah.
searching for a value. So is 4 equal to 42?
No. No.
Okay, next one. Is 8 equal to 42?
No.
Is 15 equal to 42?
Nope.
Okay, so you just get the gist of it now. So we'll keep going and keep going until you reach the end of the list. So we can clearly see here that binary search is a lot better, and even better for larger lists. So the only drawback is that the list will have to be ordered before that, and even then, sorting actually takes longer than searching. I'll explain why. Uh-oh. Why is it not? Okay. And if you didn't see the note there, actually AQA haven't given any advanced information for paper 1. It's only the advanced information for paper 2 that they've given, and my whiteboard isn't working.
It broke.
Yeah, something's wrong with it. Right. See if we can get this fixed first. Right, okay, it's okay now. I'll get rid of this note. Okay, so we've done searching, now we just need to go briefly over sorting. Okay, so which of the sorting algorithms you learnt was a simpler one?
Bubble sort.
Okay,
Merge sort.
Yep.
okay, so one was bubble and the other was merge. Okay, so bubble sort, we'll shuffle this up again. We'll have 23, 15, 16, 8, 4, and 42. So, first, how would Bubble sort start the algorithm? So, what values would it look at first?
23 and 15.
Good. So, these two values are compared. So, are these the right way around?
No,
So, how would the algorithm actually know that?
because 23 is bigger.
Than 15, and 23 is in like the index before, and I'll come to arrays in a bit. So
Yeah.
it will then rewrite the arrays, and it'll just edit 16, 8, 4, 42, and then what would happen again?
16 and 8 will switch.
Not quite. So the next pair along will be compared. This one, 23 and 16. Are they the right way around?
Nope.
Okay, so 15, 16, 23, and so on. So you can see actually why this algorithm is a lot slower, because by the time you compare all these, you'll actually find only this largest number is in the correct place, which happens to be already. Now, for the sake of making it more satisfying, we'll use merge sort with 8 numbers on our list. So I'm going to use 8.
Nathan, what are
1,
you
2,
playing?
3, 4, 5, 6, 7.
What are you
So
playing? I could just
we have
hear
8 numbers on this list. We can easily do with merge sort.
something. Yeah.
Okay, so what does merge sort first do? So let's say we have all this as one big list. This is an important step. Yep, so keep splitting the list. So you'll have 2 sublists with 4 numbers each.
Then it'll compare them. Like,
No, then it'll split it.
oh yeah,
and
split it
then
again and then.
Yeah.
Yeah.
Yeah, you keep
and then it'll
splitting it
compare
again and
them
again.
time.
Yeah, until you get individual elements. So this is actually a bit like a tournament, really. Like a knockout tournament, almost. But you're just putting them back together the right way. So you'll have
Yeah.
individually 23, 42, 8, 15, and then you have 16, 18, 22, 25. So, where would we start with merge sort?
23
Now,
and 42.
okay,
23 and 42, yeah.
good. Now, we want to put these two numbers together back into a little mini list of 2 numbers in the correct way. So, what would that become?
23 and 42. They are the
Okay.
same way. Right way.
Okay, so I'll put brackets around to show that it's like a list. Now, what would you do with this pair here?
Keep the same.
Be the same.
Okay,
Yeah.
8, 8, 15. This one is also the same. And then
last
this
one.
one. Now, when you actually merge larger lists together, have you actually ever wondered how they merge them together?
Yeah.
So, because if you were to write this as an algorithm, if you're bold enough, you would actually get the computer to look at the first element of each mini list they want to put together. So you've got 23 first in this list, and then 8 first in this list, and they would actually pick out the smaller one. So first number is the smallest, 8, and we kind of ignore that anymore, and then look at the next one. So pick out the smaller one, 23 or 15,
15.
15,
and then you got and this other bit, 23, 42.
23,
And now let's try the same with this here. So pick out the
16,
16. Now we'll remove that.
18.
Ooh, does that slide for you?
Yeah. It's fine.
125.
22,
Yeah.
25.
Yeah. Okay, so now we got a bit of a more of a mess now. So let's use the same method. So we'll get the first
8,
8. Okay, let's get rid of that. Next one.
15.
15.
Maybe like 15, 16, 18, 22,
Whoa,
23.
whoa. Hang on a second.
They can count.
16,
I know, right, Diego.
18,
Alright, have you stole any sweets today off anyone?
No, I bet in
22,
Paco.
Good boy.
Yeah.
No steam.
Well, you were
23.
north of Drop and Junk Junction.
Okay.
Me and the boys had something dysfunction.
Oh yeah,
Good.
boys.
Okay, so that's
Do
merge
you know
sort
what's
done.
funny? My
Thank you.
internet's dead shit, bro. It's taking it. Oh, it's taken 4.5 hours. Shut up.
Language.
Shut up. It was an accident. It was a miss. It was a misclick. It was a misinput.
Right, you're gonna have to make me edit this again. At least
No,
it's
it
not
was
as
just one. It was just
much.
one.
Yeah.
It was just one. It was just one.
Yeah,
You
I
don't
have
need
to
to
still
edit it,
censor it.
man.
I'll have to still censor it.
All
Okay.
right.
At least the Matthew
Click.
Post time, bro.
One
Okay.
sec, I'm just gonna mute myself and let it all out.
Okay, so now we get to some actual programming stuff now. So we got our basics, and we'll do these two in one. So do you remember what's meant by, let's say, a data type?
Yeah.
Like booleans and shit.
Okay, so you got what
String.
Boolean is one of them.
Yo, you naughty boy.
Oh,
String.
sorry. Like,
Oh yeah, swearing.
Yeah, that's gonna be a big long beep there. Right. Okay, so any other data types you remember?
Into
Integer.
Yeah.
Real float.
Well, this ties in with the numbers, a real / float. String. You don't think?
Division.
Okay, so that comes into the operations actually. So
Yeah.
your four operations, which is obvious, your plus, minus, times, divide. But you need to actually remember how you'd write these two, especially in Python.
Oh yeah, divides the forward slash. And
Okay,
then
divide is a
times
forward slash,
no.
and times is just in a little star. It's like when you go on
Yeah.
those
Straight.
terms and conditions. Yeah. So,
terms.
Lucas, you mentioned integer division.
Yes.
Okay, so what is integer division?
It'll only display the amount of times the number goes into it, not the remainder.
Yeah, so it's like
Or is that?
it kind of rounds down. So if you did, so it's represented by a double slash. So if I did, let's say, 20 and then did integer division of 6,
Was this needed?
you'll need to know this. These are basics anyway. So the only 6 can only fit into 20 like 3 times. You can't go over anymore. So
Yeah.
the real actual answer would be like 3 point something, but integer division just gives it as a whole number, rounded down. So like 3 here. So you also mentioned the remainder. How would you get the remainder of something? What operation would that be?
The modular division.
Good, modular division. Now, in Python, this would be represented by a percentage. So if I were to do, let's say, 14, and then modular divide this by 9. Just don't know why I did that, but you would get like your 1 and your remainder would be 5. Okay. So yeah, so the modular figures out the remainder.
Alright.
So do you remember back in primary school, for example, they always told you, for example, if you divide them, these, let's say, sweets between your friends, you'd have, let's say,
More.
yeah, 1 each, but then you have 5
No.
remaining. Like,
Oh,
you have to
seven
write it as 1,
is
remainder
seven
5.
still somehow fat.
So that modular operation just gives you the remainder. And this actually is useful to tell if something is a multiple. Because if something, or a factor, if something is a factor, you'll get the modular given as 0. So, for example, we know 5 is a factor of 15 because 15 mod 5 wouldn't give us any remainders, like it'd give 0.
Mm.
Okay, so that is the data types things done. So we need to just go over variables quickly as well. So does anyone remember how variables are declared in Python?
It's like the
Yeah.
variable name and like equals, isn't it?
Assignment.
Yeah. So you would only use a single equals. Okay. So let's say I have my variable name, my score. Why is it turned out purple?
I keep it purple.
Purple is like kind of just to render stuff like in Python. Hope Jamie's on here as well, if he's here.
He's online, but he does not want to join.
I told someone to remind him to join here, but
Damn.
okay. So let's say we have the variable my score, and after this equals, you can put whatever value you like, really, but it's got to be appropriate. So, what data type would be appropriate for a variable called like my score?
Integer or like float.
Real.
Integer,
Yeah.
yes. So integer, something like 8. Or sometimes if you're having it at the start of a program, you might have it, let's say 0, and then just have it slowly add.
My
Now,
Wi-Fi is so garbage, bro. Oh my days.
now that we've done that, you might also be able to assign variables arrays. So arrays are basically lists of things, and you can have whatever you like in them. You can have a mix of integers, strings, and so on. Now, what makes... So, do you remember something called indexes with arrays?
No.
Yes.
So if I
Yeah.
had a random array called age, and then I had the values in, let's say, 16, 22, 9, -1, 2, 6, like that. Now, indexing points to which bit in the list I'm looking at. So usually you would mention this a part of the list in brackets. So this is where you put your index. And then indexing starts at 0. So you'd be given a reminder that indexing starts at 0 for Python. So that means if I were to write this and then even to, let's say, print age index 0, this would end up printing out 16. Yeah, 16. So let's say what would happen if I said to the computer print age and then index, let's go 3. What would it print out?
-1.
Good. Now, let me test you something here. What if I told age, like the computer to print out age index 6? Think carefully here. What's the computer output?
16.
Would just be like nothing.
Let's think. Right.
Syntax error.
Yeah, so this
Yeah.
is a syntax error because where is age 6?
Not there.
Nowhere.
Age, like index 6 doesn't exist because 0,
Yeah.
1, 2, 3, 4, 5, 6, so it doesn't exist. So yeah, you'll get error.
Ah.
Yeah, and this I'd say is not exactly syntax error because there's actually nothing wrong with the print, the array. It's just this here, and that just causes it to, well, it doesn't work. If that happens, it's like called a runtime error.
Do we need to know like what error is which or not?
Sometimes, yeah, if it can be pretty obvious if someone's, let's say, done. That's like a syntax error because that just won't work at all.
What
So what
errors are
exactly is
there?
a runtime error?
runtime error is
What's the
like, for
exact
example,
difference?
if you how to explain? Yeah, a runtime error can actually be where the program actually works, but it doesn't have the result you wanted, if you like.
Yeah.
So, if, for example, if you expected to the result of this algorithm to be 5, but somehow it turns up as 900, you know it's worked, but something's gone wrong there. It's not, because after all, computers do literally what you tell them to do.
Mm.
So,
I got you.
I've done arrays. Now, we'll tackle these two together. If and else statements and then loops. Okay. Does anyone remember what is meant by selection?
Uh, only like prints if a certain condition is met.
Good. So it will select a piece of code depending on, well, a condition. So we're going to use an if statement. Let's have a very simple algorithm to check if, let's say, someone is over 18. So we'll have the variable age. Now, how do we make sure that a user will only input an integer into this?
Int input in it, not in that.
Yes,
Yeah.
it's
Yeah,
int.
that'll be right.
Int bracket input bracket
Yeah.
bracket.
Yeah, and there's a little trick as well. What you can do here, if you want to save a bit of time, and the question tells you to prompt the user, or for example, say, okay, input your age, you can actually put what you want to say to the user in these input brackets. You can say,
Mm.
enter your age. And then it will just have that space, and then just that flashing bar tell you to input your age. Now, let's say, how would we determine with an if statement if someone is over 18?
If age
If
is over,
age
it's more than like
Equals
18.
equals.
no
No,
equals bigger than
Oh yeah, that.
18.
Right, so we have our
Right.
variable. Now we compare it with the greater than symbol, which I actually forgot to tell you about in the lesson. So if it's greater than 18, what code shall we write? So what shall we print out? Your choice, actually.
well done.
Print
All right.
correct.
Congrats.
Yeah. Well done.
Go by rum.
Go by rum. Perfect.
Yep, go ahead. It's your choice.
Amazing.
Now, what would you usually end an if statement with?
Else.
End if.
Hold on.
Oh yeah, end if. Yeah.
Oh,
End
that,
if,
yeah, like
that's actually
colon.
end if is actually pseudocode, but you're actually right
Oh,
first time. It's else. Remember, this is Python.
damn it.
Yeah, Lucas, I know you like writing in either the
That's bad.
flowchart or the pseudocode, but yeah, Python is the closest thing we can get to the real world so far.
Yeah.
So else, so why might the code under else be run instead?
If it's not bigger than
Something
18.
else.
Yeah, so if this
Is that an
statement
equal
here,
sign after else or like a colon?
yeah, so the
Oh, yeah,
colon
that'd be
basically tells us to
colon.
like write stuff, and if you've noticed as well, I have indented this little piece of code here because after you put the colon, you need to indent, so you need to put it slightly to the right to show that's the code you'll run if that statement above is true. So this else
What about
statement like is
sorry,
run
not to
when
interrupt.
yeah, when all the other statements are false. So if your age is less than, if it's not greater than 18. Yeah,
Okay.
Nathan, what were you saying?
What about if it's like equal to 18?
Good question, because the
Don't you have
greater
a
than,
symbol for that though?
yeah, greater than like
Yeah.
strictly means it must be larger than. If it's equal, then it's not greater than. But you can actually have greater than or equals to, like this. So just put the
Does
equals
equals
before
always
it.
have to go before it? Yeah.
Um,
Or can it be after the greater than
before or
sign?
after. I think they'll let you off which way
Ah,
around.
okay.
I'm not sure. They'll
Left
let
and
you
right.
off. They'll know what you mean.
Yeah.
So let's finish off the program. If else ages, as in the age is not greater than 18, what shall we print out this time?
Go away.
Yeah,
Naughty,
pretty
naughty.
Naughty, naughty.
No,
Why do you give
Right, innit?
naughty, naughty,
A horrible way to spell.
go away. That's
Yeah.
that's
Or
that's
make
the end
them
of our
up.
program. Naughty, naughty, go away. You shouldn't be here in this alcohol store. Now, we've actually gone over subroutines in the starter. Now, have all of you done trace tables?
Yeah.
Pretty much.
We
I
did,
think
Nathan.
so.
Yes, we did do that. We did.
We probably did, but I don't remember it.
Yeah, we know. You always wear that sunflower hat.
Yeah.
Yeah.
Right. Do
I'm
you
looking
remember?
stylish now.
Do you remember what you usually used trace tables for?
Selection.
Summer.
I forgot.
Diego, have you got your book? Because
No, it's
I ain't
not
got
me.
mine. Nah, Miss Beck, it was just like, yeah, I'll
Sorry.
give you your book on Friday, but she didn't give me it.
There's like a while loop.
Oh yeah, we actually need to go over that. Forgot almost.
Oh.
Forgot.
Oh,
Right.
Damn.
So a while loop, it's also functions with statements. So if I were to do, let's start the algorithm. So let's say a equals 0. This is a very simple one you might get. So while a, black pen please, a is less than 6.
Oh, yeah, I
We'll
remember
actually,
doing this.
yeah, we'll do trace tables with this as well. Print, we'll say print a, and then we'll say a equals a plus 1. So I'll actually write down the line numbers for you.
Hmm.
So line number 1, 2, 3, and 4. So in the trace table, you would actually get something like a as
Oh
one
wait.
column.
Oh, we did this like a lesson ago.
Yeah,
I remember
line
it.
Yeah,
number.
we did.
Like we'll start at you'll leave your blank spaces to write your lines, and I'll write something as well. So statements. There might be a column for a statement. So let's say we'll start at line 1. A is 0. There's no statement there. Line 2, there is a is still 0, but you don't actually need to write anything. You only need to write in the column when the variable like changes, like if it'll increase, get replaced, whatever. Then the statement here is a less than 6.
Is the statement the output?
The
Oh, the
statement,
true or
no,
false.
that's like, yeah, the true, if a statement would be like true or false, yeah.
Ah, okay.
So is a less than 6 right now?
Yes.
Yeah.
Okay, so we'd write true, and then it would go to line number 3. It would just print that out. You don't need to write anything in this case. Sometimes it will even have another column for output, and you'll have to write the output.
Yeah.
And then line 4, okay, what happens to the value of a now?
2. 1 even.
Okay, so let's
Add
see
1.
what it is. So a will be assigned the value a plus 1. So what was a?
0.
Okay, so a will be assigned 0 plus 1. So now a has a value of 1. So what this does is this increases a by 1.
Mm.
And then you will just continue this over and over again. Now, this will repeat until a becomes what value?
6.
Good, yeah, because then it's no longer less than 6, and it will just continue on right here with whatever code is there,
Yeah.
but there's none. So it just finished the program. So
Mm.
you might need to also do for loops. And actually, for loops are an easier way to write these kind of, well, adding one after the other. So what you usually do is you start with for, and then you'll have a variable name. You can call it whatever, but for tradition, for people who've coded with Python for a long time, we tend to use the letter I. And then we use, say, in something. Now, in this space here, you can either have things like count. In this space, it says if I have, let's say, count 6, we'll repeat whatever is below 6 times. You can have also range, which does a similar thing, but you start at a value and you end at a value, like just before it.
Yeah.
So I could, let's say, write for I in range 0, 6, close brackets, and then remember this, you'll, like the while loops, you'll need to write a colon as well. And then indent whatever code you have here. And if I were to, let's say, just write print I, it would actually function the exact same way. So it would start at 0, print that out, it would actually increase by 1, because that's already included by the for I in range function. And then keep going until 6 is reached. So I don't know if this might be useful to you, but FYI. You still there?
Yeah, we're still there.
Okay, so we've done trace tables. Okay, now you might be asked a lot of questions on, well, to criticize someone's programming. So what are the things you should try and avoid doing when you have, let's say, this big programming project?
Um,
Do you want
uh,
Like
Errors.
variable
your
names, isn't it?
algorithms to run like fast or slow?
Fast.
Okay, so your objective as a programmer, okay,
efficiency.
yeah, so make a program efficient. So basically, well, don't have to keep writing the same thing over and over again. That's why you have these if statements, these while loops, and so on. Now, if you were to, let's say, stop programming for a few years, but then come back to it and you look to this program, how would you make sure that you know what this program does? Think about, let's say, variables and the names.
Good variables, like suitable ones, isn't it? So like
Yeah,
matches and that.
so
Yeah.
suitable variable names. Try and avoid using single-lettered ones like S, something like that. That was actually one of the questions in a past paper. So why was the identifier or the variable S not suitable? Because first its purpose wasn't clear, and then when you really to come back to it, you'll be like, what? Though to be
Yeah.
fair, do you remember something called comments on Python programming?
Yeah,
Yeah,
half
yeah.
shot.
So these
Yeah,
are
that-
actually in red. So you basically put a hashtag here, and it's like a little note here. It doesn't interfere with any programming. So you can say when this was made. You can even say like purpose or something. You can put it if you want in the exam, but if you want, it's your choice. Now this brings on to maintenance. Now, thing is with maintenance is if this is a really big project, the code will change time and time again. Well, not majorly, like one big bug fix or whatever, or a feature fix. But, and again, this is why we use these subroutines. So we have a subroutine that, and then first defined at the top, and then used again and again, and you only need to change what's in that define bit of the subroutine, and it'll change everywhere else. Okay,
Yeah.
so, and just a little extra point on making programs efficient. I can't remember the question, but to make a program more efficient, you need to have fewer lines usually.
Can you say that you can like use subroutines as well?
Yeah, you can say as well. But the point of having fewer lines is you can't just say that. You actually won't get a mark for this in the exam. You'll have to also say that uses less memory, maybe.
But once you say like how you achieved like
Mm.
fewer lines,
Sort of. So, do any of you remember this little cycle called like fetch,
yeah,
decode, execute?
Yeah.
Yeah, this is
Yeah, I
all to do
remember
with it. So if you have more lines, this is going to be happening more often, so it's going to take long for your program to do it, whatever it is. Okay, so that's part one covered. So that's all the programming done.